1602. Let's get started. My name is Michael Duyek. I'm working for Ergon Informatik as a product manager. And in this role, I'm responsible for the Anomaly Shield. I have with me Alex. And Alex, it might be good if you could introduce yourself quickly.
Sure. Hi, everyone. I'm Alex Born. As the title slide says, I'm a data scientist and basically the one who is researching and implementing Airlock Anomaly Shield.
Thank you. And what we're going to do during this maybe 1 hour is we have an agenda where first I'll talk a little bit about what the Airlock Anomaly Shield update is. Then we're going to have a deep dive into anomaly detection. We're actually looking at 2 triggers and the models involved there, how they work, and why they cannot or why they should never create false positives. Then Alex is also going to have 2 demos in this part there. Then Alex is going to spend some time in the research lab and tell you a little bit about what they're doing right now. And at the end, we're looking into operational aspects. I have 2 Mentimeter questions for you prepared. And at the end, we'll have questions and answers. If you have a question of understanding, just barge in, unmute your microphone and ask, or you can actually also ask questions in the chat, whatever you prefer. So this session will be recorded, and the recording will be available after the webinar, just as a word of warning that, yes, whatever you say or type, it will be visible later on, and it will be available through the internet. So let's get started with the Airlock Anomaly Shield update. What's the purpose of the Airlock Anomaly Shield update meeting? Well, we want to share information about the Anomaly Shield. The Anomaly Shield kind of is difficult to understand at first because there's machine learning involved and the mathematical magic is not very obvious. So what we want to do is we want to share how those features actually work and why they do work for you. We're going to give you previews of upcoming features and innovations if we have something to share in that area. And as you already know from the agenda, we're also giving you updates and insights from the research team. Last but not least, this thing will have a question and answer section. So whatever questions you may have, just post them or ask them at the end, and we'll try and give you as many answers as we can. From the organizational point of view, the Airlock Anomaly Shield is something that's going to happen from now on forward twice a year. The first one is always going to be somewhere in May, and the second one in the year will be in November. The format is going to be a Teams meeting, as you already can see. We'll record it, so if a colleague of yours wasn't able to participate, he or she can watch it later on. The participants in the meeting are by invitation only, so we're sending out the invitations. They're current and prospective customers of the Anomaly Shield, and we're expecting this meeting or this presentation to take roughly 1 hour. So now you should have an understanding of what to expect from the Airlock Anomaly Shield update. So let's deep dive into the anomaly detection. The first topic I have for you starts with the Mentimeter, and it's about bot management. I think most of you already know how Mentimeters work. Either you can go to this website, menti.com, use this code, and you'll see the questions there, or you just use your smartphone to scan this QR code. And with regards to bot management, we have 3 questions for you, or 3 possible answers.
Could you please share the screen? We just see you.
Okay. I'm terribly sorry you didn't see any of my slides.
Now it's working, thank you.
Okay. So go to this website, menti.com, and use this code here, or scan the QR code with your smartphone camera. It will lead you to the same thing, and you'll have the question, what's your take on bot management? And there's 3 possible answers. 1, you don't care about bots, which could be a possible answer. The other thing is that you're afraid that actually the Anomaly Shield causes problems with benign bots because it might actually deter them from scanning your site. Or, which of course is what I'd like to hear most, is that you're using the Anomaly Shield without problems and that the benign bots are not being deterred. So we've got 7 responses. Let's see, there's 2 that are still thinking about it, only 1. Five. There it is. So let's see what the responses are. So most of you say that you're using the anomaly shield without problems. 2 of you say that you're afraid that it could cause problems, and just 1 says that they don't care about bots. So that's excellent. The 2 that are afraid that the anomaly shield could actually cause problems, you have to listen up now. The other 4, they already know that it works, but maybe you can learn something on how it works. So what's the bot management challenge that we're facing? It's a very simple graphic, and on the top left, you see the end users. Those are, of course, human beings and not bots. We need to be able to, with the anomaly shield, to discern those. Then we have benign bots, Google search engine, Bing search engine, job search machines, things like that. These days, probably also agentic AI, searching the internet for answers. And then we have attackers and, of course, malicious bots. So all the automated attacks that are happening out there should be in those categories. So we want to do with the anomaly shield, we want to be benign to the benign bots and allow them to go through. And we want to deter the malicious bots. And for that, we have a trigger in the defaults that we call malicious bots. So what you see here is a screenshot from the anomaly shield. It's a trigger. And in this trigger, we're configuring what kind of models down here actually should be activated in this malicious bot anomaly shield trigger. With these 2 models here, we're deterring malicious bots. And here's an explanation why it works that way. The first model that we're seeing is status code meta here. And status code meta reacts when an IP address or a session basically creates many bad status codes. So those would be 400s and 500 status codes. If a session or IP address does that, we consider it a bad source, and Anomaly Shield will start deterring that. Client behavior is the second model in here, and client behavior basically tracks on what you're doing with your mouse, your keyboard, and touch screen. And if this behavior that is being reported there is normal human behavior, then client behavior is, well, it's human and will not react. If it detects a bot, it will flag it as this is a bot using the website. So if we're combining the 2, so you get bad traffic, and you're detecting it's a bot. So that's the combination of the 2 models. And you have a bad bot. And bad bots is what you want to, where you have rules that you want to deter them. The nice thing about this is if the status code meta does not react, and it would not react with the benign bot. For example, Google search engine will not cause an extraordinary number of 400 return codes or 500 return codes. Then this model here will not react, and therefore just detecting it's a bot is not going to do anything. It will still allow the traffic through. Now, to show you how this works, Alex has prepared a little demonstration, and he's going to take over the screen now and guide us through that demonstration.
Okay, let's share my screen. Okay, now you should see a configuration of a gateway machine. I just zoom in a bit for easier following. So what I've prepared here is basically a small test machine. So it's a bit easier to follow with the screenshot just shown in the previous slide. And what I configured is basically a simple anomaly shield app. And what I do is basically saying, okay, the trigger, or basically the detected event, or the event I would like to detect, as shown by the slides, is here. And also to make following a bit easier, I kind of bisected this one into separate events, like I detected the bot and I detected actually bad use of status codes. So I added it for a bit of more of granularity in the logs, which we will see. I have a freshly installed machine, so I should have basically nothing here. So nothing happened in the last few minutes. And then one of the most simplest ways to produce bot traffic, so to say, is basically a curl script. So we can say, okay, how about we just send just basically few requests in a loop. And basically what I do is just also add a bit of a sleep, so it's not just goes instant, but while I talk, actually something happens. So now, in the meantime, the machine is hopefully waking up, generating some logs. So that's probably the idle thing. And now I just zoom out once again to see what happens. You see there are some summary logs happening. Each request in curl is basically a new session. So what we expected that not a session evaluation, but basically an IP evaluation happens. And as you see here, we get something and it says client behavior showcase triggers. And looking into the details, and now it's nitty-gritty details, so bear with me. It basically says here you have a client behavior, and it says it's one. So basically, it's definitely a bot. But as Mike said, right now this one is harmless. So it's basically just some kind of an automated script surfing through your website or my website at this point. There should not be no like repercussions at this point, but at least it says, okay, this one is definitely a bot. So now we could say, okay, what happens if we do once again some harmless stuff, but not basically each request is one session, but we bundle them in a session. Does it behave in any form different? So we still keep the curl. Now we're at the cookie store, send the same 20 requests. All of them are harmless. And well, the idea should be that once again, we will see that there's some kind of detection of a bot, but it's still a harmless bot. So let's refresh. So now we should see that if I add a session ID, that the session ID stays fixed. Yeah, now I got one. And it still says here it's a client behavior showcase, so it matches something against not the actual detection of a bad bot, but just some sort of a bot. And refreshing once again, yeah, this one looks good. And here you see it now it says it's a session status. So now it's bundled by session cookie, not just by IP. And once again, client behavior one, the nitty-gritty details, basically says, yeah, it's a bot, but a harmless one. So now what would we need to do to actually trigger a bad bot detection? Now, as Mike said before, we need to combine both of them. So how about my curl script actually tries to access some sort of WordPress admin PHP or something? So now I just say in the loop, how about you just go for the WordPress admin PHP and just repeat it. Hopefully you get there, or maybe you don't get there at all. So what happens now is I refresh once again. He goes through the requests. You see here the old session is killed. New session started. And let's see what happens here. Now, the good part, we see a bit of a new wording. And if I fight successfully with my screen resolution, we should see that it basically says now it's a default hard action on bot. So what would happen now is basically that it says, yeah, we have bad interaction with the ad site and it's a bot. So both things combined basically trigger our default rule. And the default rule would normally block the IP. That's why I put it in log only. Otherwise, I would not see anything on my screen right now and the session would be over for me. And that's basically the simplest form how the bot traffic is detected. And now, obviously, not everybody scrolls with curl, but as long as you are sort of automated script, either via self-made curl, self-made Python script, some sort of a software, and you do actually some legitimately bad requests, you go here. But as long as you're just a software, just a curl script, or just a Python script, but you interact gracefully with the application, as you have seen before, it does not trigger this default hard action on bot event. so far for this particular use case. Mike, I will mute myself and stop sharing so you can take over again.
Thanks, Alex. I hope I'm sharing my screen now. Just few more words on client behavior. Because we actually promised that we do a deep dive on things behind the scenes. Client behavior has a few properties that make it different from other models that we have in the Anomaly Shield. To make client behavior work and to determine on whether someone is using the application as a human or whether it's a bot, we have to inject some JavaScript, which then is used to track mouse, keyboard, and touch information, sends it back to the Anomaly Shield for the Anomaly Shield to interpret it. If no JavaScript support is available on a particular page, then we will automatically display an error page. So if you really have the case where there is something you want to expose where JavaScript support is not required and you want your clients to be able to disable JavaScript support, you can't use client behavior anomalies because they just won't work. Another thing I wanted to mention here is the way it's implemented. We do not require authenticated sessions. We don't want to recognize users as, for example, a username or that we can collect data on a per user basis. That was also always a worry for some customers that we might be doing something that is on the fringe of the data privacy laws, but we're not doing that. The only thing client behavior does, it takes the information, interprets it, and determines bot or human, and that's it. What client behavior cannot do is cannot differentiate two humans, user one and user two. That's not possible. And it's definitely not possible for client behavior to verify a returning user like this was Alice, and we know it's Alice because we already seen her login before. Things like that is out of scope for client behavior. Good. So that's it for client behavior. I don't see any raised hands. I look at the chat quickly. Now you're not presenting, right? Good. Now I noticed that as well. So let's move on to another topic that I think is very important, and that's the protection of the login screen. Protection of the login screen is something that we've been offering since a few releases already, but somehow I think that it's not that well known that actually the query parameter model is able to do exactly that. The query parameter model is something that protects any kind of form. And it looks at those forms and evaluates them to check on whether a form parameter is being used more often than regular in other sessions, or whether the values in a form parameter are being used more often. So if I translate that to the login screen, if you're trying out different usernames in the same session, doing it once, okay. Doing it twice, yeah, maybe not. But if you do it 100 times or 1,000 times, like in a password spraying or credential stuffing attack, then it's definitely not okay. And the form protection or the query parameter model offers you will do exactly that. And now for the explanation how it does that. So again, a screenshot of the Anomaly Shield trigger. And now this time it's parameter probing. And you can see down here, we have, again, our models. And it's the isolation forest and the query parameter model that are being combined to actually trigger actions here. The isolation forest is a difficult model because what the isolation forest does, it inspects various request parameters, it clusters them, and then basically checks on whether a given session is very far away from those clusters or it's rather close to those clusters. Those that are very far, it considers anomalies because they're not behaving as other sessions do, and that's when the isolation forest starts triggering. The query parameter model is exactly what I told you before. It reacts if parameters in a form are used too often or with too many different values. And it doesn't care whether it's an IP address doing it or a session doing it. So if we combine those two, we again get the same thing. The isolation force says this is bad behavior, it's an anomaly. And if we then add the knowledge that forms are being abused and have both of them combined, then we can say this is someone that actually is trying or messing around with a form way too much, and we don't want to allow that. And the login screen is just such a form. And Alex is now taking over, and he's going to show on how a password spraying or credential stuffing attack is being stopped by the Anomaly Shield.
Okay, so first of all, I start sharing my screen. Okay. We need some prerequisitions. So first of all, right now I was surfing with my internal Ergon IP, which is whitelisted on our own systems. And to conduct a bit of a mischief, I'm gonna go to the IP I'm given from my mobile carrier and basically do a hotspot. So now it basically says mobile carrier, so my IP changed. And pretty sure there's a short pause in showing off my screen due to the change of the network. Now I see that I'm back. And okay, so what I'm gonna to show. So I thought that basically showing once again just some sort of a dummy system is a bit of boring and less of a skin in a game. So what we're gonna do is basically show how normally somebody would actually try to go through some credential stuffing. And I was considering writing a known Python script, and I was like, nah, that's not the way to go. So what we can do is basically saying, okay, somebody would always use either burp suite or subproxy. And then basically what people would always do is go to the area of interest. Area of interest is currently our secure ergon.ch. So basically exactly where everybody logs in. And now let's say, how about admin and admin? And this would be a disaster if we actually get logged in. So it gracefully failed. And now let's see whether I find the post request. So with some sort of software to get some automated help, you would see, oh, okay, I have some sort of a username and password. And now I could iterate through the parameters. So what I could do is basically say, okay, how about I say this one should be tried? And let's say we just either type what sort of parameters should be tried, what sort of values, or let's say for the demonstration purpose, somebody could say, how about we just fuzz the regex and brute force it? So this one would be definitely like a brute force. We don't have a few billion years to wait. So let's say just take very short ones and have a maximum of a payload. Also a bit of randomness. And then you see basically this is what we would try to get through. And then I say, okay, how about we start the fuzzer? So instead of admin, we will get each and every value from the list. So now it does something. And once again, this goes to the live system. Different way of attacking would also be to say, how about instead of a fuzzer, which is a regex, we can also add a payload from a list. How do we get a list? We just go and Google something like 1 or 1000K or 10,000K most common passwords. Here we go. Grab the first link from a GitHub. Yeah, then it breaks down, but that's okay. And what we have here is basically, I already download the list. And then I get the most common passwords. And I can just say, okay, how about we add the most common passwords here from a list. Okay, there's a lot of stuff going on. add, start. Now it takes a bit longer. Okay, while he's doing it, and I have to wait a bit before switching IPs, the interesting part, what exactly happens on the live system, because once again, there's more skin in the game if I actually perform on the live system. So I stop here. It's done its job. Yeah, shutting down the database also sounds nice. Everything's done. And now we have to switch the IP so I can look at the logs of the productive machine without being denied by the IP. So there will be a short pause most likely because I once again switch the IPs. So I see that I have most likely to reshare my screen because you right now you still see the pause of my screen being held on. Oh, now it said I have to share it again. Let's just wait a second. Give me a short moment. The change of IPs was not highly regarded by teams. I assume teams already said that it's not that great that I switch IPs on the fly, but let's see what happens now.
We can still hear you perfectly. Your camera is turned off right now.
Because I used two computers because I already knew that it would be a bit of a trick to just switch on the fly and not being kicked out. Okay, so I'm back and let's see how it goes. Okay, so I'm back to my Ergon IP. So if I check the IP, it says Ergon Informatik, so that's good news. And hopefully I can go to our productive machine and see whether I was able to achieve some mischief. So active, that's good. And now the question is, what did my IP achieved over the time? So I already know what my IP was because I've checked it before. And I see the IP was active here around basically a few minutes ago. It already says a lot of blocked, as you can see here. I will zoom in a bit because I assume it might be a bit hard to read on a larger screen. And you see that I sent something around 11K requests. And the first 1K were a farser where I just had basically brute forcing random strings. And the next 10K were actually an educated guess from a list. And now if the 49 is basically just the first connection I opened up. And if we just say, okay, how about we remove the blocked requests or look into the distribution of the blocked requests, we basically see that in the first 5K of requests, it actually looks into, we had, and now we have to basically count a bit. The first 49, that is the first request and all the resources being loaded, but let's say the first 50 were allowed. Then I got something around 60 to 70 passwords through, and then everything was blocked. And if we actually would basically look into the first attack and the second attack, so this is like the combined view, but if we just click in the second attack, then we know everything was blocked. Because once again, as soon as it recognized this IP is doing nothing legitimately good, it basically blocked the IP for 2 minutes. And I was a bit of greedy, so to say. So I basically made a second attack within waiting for 2 minutes, and the IP was still blocked. So from there, we can say, if I just go back to, let's say, back in time, we see that what actually happens that it kind of blocks really fast, and then it stays blocked for quite some time. And now, as Mike said, I don't specifically train Anomaly Shield to say this one is an application where we have to type in password and username, and this is an application where you have to type in some sort of maybe a search field. So basically, it just realizes, oh, there are some parameters, body parameters, and also query parameters which might be used, and then the model basically finds out what is like the correct distribution, and then adds a bit on top to basically account for people who are like forgetting their passwords or maybe use excessive search. So you don't have to actually go in and configure each field separately or say, I would like to have this sort of values for this particular parameter field. I would like to have different kind of thresholds for that particular parameter field. So this one is basically done automatically. And as you see, this is the live system. That's what we use. And yeah, basically, as Mike said, it blocks where it should block. Yeah, I will mute myself and stop sharing, Mike, so you can take over once again.
Thank you very much. That was a short demonstration how the query parameter model combined with the isolation forest can help you protect login screens. So it's an argument why we think that even those that have mostly authenticated traffic on their websites really can profit from the Anomaly Shield, because whenever you have authenticated traffic, there must be some place where you do the authentication, and that place there you're vulnerable. That's not just the login screen, but that's also, for example, password reset and other public self-services that you might expose, like an account unlock, things like that. That are exposed directly on the internet and that can be protected with the Anomaly Shield. And as you've seen from the statistic, in this small example, we were able to block something like 97% of the traffic. If you're trying to do password spraying or credential stuffing, and 97% of your attacks are being blocked by the Anomaly Shield, then that's good news. And last but not least, the system behind the IAM actually did not see those 97% of the requests at all. So it wasn't loaded with those requests. It was doing hopefully other sensible stuff, authenticating real users instead of reacting to attacks. So that was it from the deep dive into the Anomaly Shield, and now we would go to the update from the research lab. Alex, do you want to share the slides, or should I present the slides and you'll just talk to them?
I guess it's best if you share the slides and I talk through them.
Good. And let me see. That would be the update from the research lab, right?
Yep. Okay, so from now on, it's just slides, so no presentation. Also, all presentations here would be very, very deep dive in the code or analysis. So I try to make it as simple and abstract as possible. So from the screenshots of the triggers, you might have seen that we use different models, and each model has a bit of a different idea what it tries to analyze. And basically, I tried to make an abstraction of what we're analyzing as separate blocks. This abstraction is basically seen on the left side. So what we check is URL data, status codes, timings, request metadata, parameters, client behavior data. And you have already seen the application where we basically check the status codes in combination with client behavior data to see whether you're like a bad bot, where we see some request metadata. That's basically what happens in the isolation forest model. And the body parameters, or header and body parameters, for example, for the logging mask security. And now, if you would look even more into detail, we already process information regarding the URL data. But as is, it is basically an approximation of the data we get, because URL data is string data. String data is kind of expensive to process, and also it's a bit of a question, what exactly would you like to see and analyze? So what we do, we basically create some numeric heuristics. For example, how deep do you traverse in depth first search or breadth first search, or how often do you jump to your parent, or how many distinct URLs are you using in your session? So these are different heuristics, and then we perform some sort of a model on the heuristics. Now, what's lacking is the text analysis itself, and it's natural to ask, well, there should be like a lot of information in the text data. How about we actually look into it? And on the next slide, there's basically two ideas of what you could do if you actually analyze the text itself. So in scope, and what I'm going to talk about more in detail, is what can you tell about the transition between one request to another, which basically always have a URL path in them. So do you actually traverse through the application similar to other people, or at least in a way which would be expected, or at least some sort of probable? So maybe you're not traversing like other people, but at least it seems like you're visiting areas which are available at the application. And different idea would be to say, how about we just look at the path themselves and say whether they are plausible within the application. And just to make two examples, which are hopefully a bit less abstract, let's say what would be out of scope with the context. Elena, sorry, the dog is eating the cable. Out of context would be, for example, if we have a page with our employees at ergon.ch, and then we get a new employee, then this page might not have been seen by a model before, but if it has some sort of a first name, last name text content, then it would be plausible within the content of that. All the other 300, 400 pages have first name. But for example, if you suddenly would have something like online shop for clothing, and somebody would say airlock.com or ergon.ch clothing, then we would most likely say it's kind of not really plausible. But now the point with the URLs, they have some hierarchy to them. Plausibility and context are not that simple in the hierarchical context. So we go for a bit of a simpler approach and say, okay, how about if somebody goes through a career website, then he most likely will traverse from one career page to another page. Maybe he also click on the people who are assigned as contacts, but it's kind of unlikely that somebody goes into the career page and then suddenly jumps into some solution design, and then he suddenly jumps to some uploads or downloads. So that does not sound too plausible. On the next slide, I basically show without too much detail what exactly to expect, because everybody has a bit of a different idea what the transition from one side to another is. But basically, if we look at a session, what Anomaly does, and we see different paths going one after another. So first of all, we do a bit of simplification. We are not interested like in the last.png and favicon.ico, whatever. So we are more interested in the first big chunk of information, basically on the level of information where the main content is. And then our abstraction is to say, okay, you're basically traversing from one large area to the next area. Then you stay in the same area, then you traverse to the next area, then you maybe jump to the root, and then you go to the next area. And that's the model input. You basically see about us, goes to services, stay in services, then you jump to the next area, and then basically you go twice again. And that's what the model sees and evaluates. And now we also have to be a bit clever about what happens if you get a new website and it have never been seen before. Then the idea is okay, but you should have seen parts of the transition before, at least how people react with the areas before or after. Let's say if between the two services we would get some sort of a new website, then at least you would say, at least I have seen people visiting services and going to services again. So it sounds plausible. And with this, we basically create a model which goes analyze traffic and evaluates the text data without being too much of a compute problem, so it's still fast. So this is also one of the main concerns, that the new model is not taking a long time and you basically do not evaluate it real time. On the next slide, I have written a few bullet points. Oh, was it not here?
I don't see that slide in my slideshow.
Yeah, that's fine. So basically, the main takeaways would be that now we added a bit of more security by processing more information. We will add it as a new model to the existing one. So now our model count goes from 6 to 7. And 2 models will be analyzing path data, the old numerical one and the new one which actually processes the text. And we tested it on standard applications where the application basically looks like a nice tree where you start with the root, then you have few underlying main areas, and then everything branches nicely below. We also tested this on basically single page applications to see how it behaves there. And well, there is not a lot of actual variation happens, but the model still works with it. And if suddenly somebody tries to do some sort of weird path in the single page application, it will also gets flagged by the model as weird. And that's basically what's going to happen in the next release. Okay, that's all from my side.
Thank you very much for that. Then we'll continue to the operational topic. And as I already promised, I have 2 Mentimeters prepared for you with regards to operation. The first one, Mentimeter, is a very simple question. Have you ever used the Airlock Anomaly Shield Quick Start? This is something we introduced to make your life easier to actually get started very quickly, especially if you want to try the Anomaly Shield. You know, there is no license required these days. And we want to hear from you on whether you've seen that or not. So I see that 9 people have logged into Menti, and they're already answering the question. Oh, 2/3 have answered. I'll still give you a few seconds. Okay, let's reveal the answers that we have. So 6 of you have done it manually. You haven't used the quick start. Well, I hope the next time that I'll ask that question, there will be a few more that actually have used the Anomaly Shield Quick Start. Now, as promised, there is another Mentimeter, and this one will have a direct impact on where we're going to allocate resources in the development. We want to get your idea on how difficult or how much effort is required to actually set up or use the Airlock Anomaly Shield. So there's three areas. One is the initial setup. Of course, if you haven't used the quick start, then you're probably going to say that the initial setup was a rather a lot of effort. Then what I would like to see is how's the monthly operation? Do you think that you have to spend a lot of effort here or very little effort? And of course, also an area of concern is the gateway version upgrades. We know that you always have to do a little bit of work for the Anomaly Shield for when you upgrade a gateway version. So we would get your assessment on whether that's little effort or if the effort actually is large. So I see that some of you already are responding. So I'll give you another few seconds. I guess that's all the answer we're going to get. So let's see the responses. So the initial setup was extremely a lot of effort. Monthly operation is a lot of effort. That's something that we definitely have to look into because we felt that with the updates we provided during the last releases, we've actually made the Anomaly Shield to be rather hands-free and do everything automatically if you configure it accordingly. So I'm a little bit surprised. I'm also surprised that Gateway Upgrade is last but then and requires only little effort because we thought that the waiting time for Model 3 training, that was actually something that is rather annoying. And we fixed that, which brings me to the next slide I have. Just a little outlook on Gateway 8.6, which is just around the corner. I can't tell you when it's going to appear on your doorstep, but I'm being told that it's pretty soon. What we've done in 8.6, and I'm not going to repeat all the webinar information that you're getting with the Gateway 8.6 introductory webinar. We've improved the client behavior analysis that we discussed today. Alex already mentioned the new path navigation analytics. That's a new model that you're going to get. We did some performance optimization. The bottom line is that we're basically able to assess about 40% more of sessions or IP addresses and prepackaged models. That's a method that we implemented to make the gateway upgrade work a little bit more smoothly. So that's it from the operational side. Alex, I'm not sure, are you going to do a demo on how to use Kibana and determine on what actually the source is of problems that Anomaly Shield detected, or are we going to skip that presentation?
Looking at the time, I think it would be nice if we skip it and allow for question if there are any.
Okay, so then we'll promise to do that next time. The next time, as I already said, will be in November, and we're on the question and answer slide. So are there any questions and answers or questions from your side and answers that we could give? I'll stop sharing and check on whether I see any raised hands or somebody want to take the microphone. Okay, Michael asks, will it be possible to only block IPs on the selected blocked app? Alex, I think this is one for you. This one is for you.
Currently, we have the dynamic IP blacklist, and it will block for everything. So not in 8.6.
You have to give me a little bit more information on how that works. If I have a rule that triggers, then I configure. If I have a trigger that basically says this session or this IP address is an anomaly, then I can have a rule that basically blocks that IP address, right?
Exactly. And then as soon as that trigger is activated, basically the IP address is added to something called dynamic IP blacklist. And then whenever a new request arrives from, let's say, different application, it basically checks these dynamic IP blacklist and says, oh, I've seen an IP which is blocked, and then it blocks. So the IP is not application specifically blocked.
Thanks for the extended explanation.
This is a quite big problem because nowadays, since IPv4 are quite scarce, there is a lot of NAT going on, a lot of mobile providers which aggregate IPs, and then you can block a lot of people at once, and even on all your applications, and not just the one which triggered the block.
Okay, I take as the feedback. Thanks.
Yep. I'll have to look into that. Then we have another question. Will it still be necessary to lead and retrain models after Airlock gateway update? I find this process to be not so straightforward and makes total time during the update unpredictable. That's a perfect question, because that's exactly what you're going to get with 8.6. I just recorded the Gateway 8.6 webinar part where I'm explaining that we found that this might be a problem for you guys, and that's why we now have these prepackaged models. Prepackaged models basically means that out of the box during the Gateway update, we will install those prepackaged models, and they will work. They're not as efficient as a fully trained model, but they will work. And if you have your Anomaly shield on full automatic, meaning you do data collection all the time and you allow it to train and apply models automatically, then during the first night, it will actually say, oh, I'm on a prepackaged model. This is not great. Let me retrain, and it will do the retraining during the night. So during your upgrade, you will not notice something. During the first night, you will already get better models, and after the 35 days, when all the data is available, because you have data connection enabled, it will again retrain, and then you will have the full-fledged models that are perfectly tuned to your application. So yes, we agree this is cumbersome, and we believe we have a fix with the 8.6 gateway release. Alex, do you want to add something?
No, just tested the feature today.
Good. Any more questions for us? I take this as a no. So thanks again for watching this webinar, and you will be hearing from us in November, or no, earlier than November, but we will be seeing each other hopefully in November when the second Anomaly Shield update will be going on the live stream. Thanks a lot, and have a nice evening, everyone. Bye-bye.